welcome Mr. Bean. Wanted to take a second here and introduce you to Mr. Bean. You may know him from beloved films and things like that. Yes, he is also an amazing math teacher. So, Mr. Bean, welcome to you. How good is he? He won a presidential award for teaching math. Does that sound familiar? Yes, Mr. Kelly did it first. Yes, we know. You just add 2 years to Mr. Kelly's resume and you have Mr. Bean's, all right? But regardless, he's amazing. Great. We're glad you are here. Bean, let's get to it. So, last time we talked about function notation. Now we really want to delve into what is a function. Before we get to that, let's talk about a couple of other things so that we can understand that better. A relation. A relation is just a mapping or pairing of input values with output values. We think of input values as our x's and output values as our y's, all right? And so when we put something in, we get something out. That's a relation, all right? A domain. Domain is a set of all input values, the independent variables, also known as the x values. So if I looked at a graph, the domain would be any possible x. The range is just the opposite. It's the set of all output values. It's a dependent variable, the y value. So looking at anything that talks about y values is a range. So if you look at this example right here, we have ordered pairs. We have an x and a y, right? So our domain would be all these values here that are x's. Our range would be all these y values. In a table, same thing. Our domain, all the x values. The range, all the y values. And you can look at a graph. You'd have to go out and actually pick out these points, but everything that's an x, so you can see this is -2. That's one of our x's. There's an x at 0. There's an x at 1, 2, 3. Those are ways we can figure out what domain and range are specifically. So let's try one here. Consider the following relation. So remember, relation is just there's an input and then there's an output. There's an input, then there's an output. There's an input, there's an output, right? X and Y. Identify the domain and range. When you're given distinct sets of points, we like to use these fancy brackets here. Very, very fancy. So if I have domain, what are all my values of x? I like to write them in order, so it's my smallest x. 0, -2. -2 seems to be first. Now, I have it twice, but I'm not going to write it twice, all right? 0 would be the next one, and then last but not least, 4. So my domain would be -2, 0, and 4. Let's take a look at our range. What would our range be? Let's see, we have 2, 4, -4 is the lowest, then -3, and 2, and 4. All right, so that is our domain and our range. We could then, of course, plot these as points. 0, 2, 0 over 2 up. That's 1 point. -2 over 4 up. That's another point. 4 over -3, 1, 2, 3. That's another point. And then -2, -4. That right there, we have our fourth point. So this is all stuff you've done before, but as you can tell, we're just going to talk about domain and range. These are very important things, all right? And that leads us to what a function is. A function is a relation. It's a very special relation. What's a relation mean? It means that for every input there's an output, right? So it's a relation for each input has only one output. So sometimes if I put an x in, I could get 7 and 4. All right? But what this is saying is if I put an x in, if I only get one output, not two. All right? So for every x I put in, I'm only going to get one y out. So for each x, there's only one y. So if we take a look here, let's take a look. For x is -1. There's only one -1. It only goes to the value of 3. For x is -2, it only goes to the value of 5. For the x here, it only goes to 1y. For this x, it only goes to 1y. It doesn't matter that the y's are repeated or whatnot. All that matters is that for this x, it only goes to 1y. Now this seems ridiculous when you look at this one because it's just like a table. But if you come over here, this x this is the same x. So essentially, I didn't have to write it here. So when I put in x on this relation, it goes to -1 and -3. Is it possible for a number to function and go to two different outputs? It's not possible. It can only go to one output, and that's the function, all right? So for everything you put in, every x you put in, you can only get one output back, all right? That's a function. Now the great thing about functions, we're going to look at a lot of graphs for this section. There's an easy way to use a graph and a vertical line. We call it the vertical line test to see if it's a function. A relation is a function if and only if no vertical line intersects the graph of the relation at more than one point. Now take a look here. I'm going to draw this. Now you need to remember that when we have a vertical line, the equation of that line is x equals a number. All right, so right now it's x equals -2. So my input is -2. I put in -2, so if there was more than one spot where it crosses this line, see it's up here, it only crosses once on this line, that means it's a function. If we're to come to over here, to this second graph over here, you can see for this example, how many times does it cross this vertical line? Well, it crosses twice. So example, for the value x equals -1, how many outputs are there? There are 1, 2. There are 2 outputs. Are we allowed to have 2 outputs for one input? We are not. Therefore, it is not a function. And we simply say, you know, it's not a function. It does not pass the vertical line test. All right? That's how we put that. It doesn't pass the vertical line test. Okay? Let's come back to this domain and a range in just a minute. Let's take a look at a bigger one first. Okay? So we have the following function. Well, actually, we should say we have the following relation, right? We don't know if it's a function. So this is a relation. Identify the domain and range. All right, so let's do our domain and our range. Now, do I want to list every single point on this line? No, I don't want to do that. All right. First of all, it would take forever. It's just not. It's impossible. We can't do it. So here's what we're going to do. We're going to look at our graph, and we're going to write in interval notation our domain and range. Now we know our intervals are, our domain is x. So right now I want you to focus only on looking left to right. Okay? I don't care what the graph looks like. I just want you to think about left to right. And I'm always going to start like this in this interval notation. I'm going to start off and assume there are numbers between these two values. All right? So down here, I'm going to start with the lowest value. Lowest when left to right would be on the left. So what is the lowest value? It looks like right here at -3 is my lowest value for my x. So I'm going to plug that in right here. Now I'm going to I have to ask myself, is it just greater than -3 or could it equal -3? Well, how do I know? Is it a solid at -3? It is a solid line at -3, so it could equal -3. All right, now on the far side, I want to know the upper limit. What's the biggest number I could have? And over here, I look at it, and it is 3, exactly 3. So my number to the most right is 3. All right, and it's in 2 places, and that's fine. Now, do we include this 3? Well, this is an open circle. That kind of means it gets as close as you can get to 3 without actually including 3. So we're not going to equal 3 on this one. All right? Now our range, I'm going to set up the same way. I'm going to start with our intervals. Now, I've seen some of you, you put these backwards like this. You don't want to do that, all right? You want to think least to greatest, least to greatest. That's how our minds, are trained to think. So range is wise. Now, when you're doing range, I want you to think just top to bottom. Don't think about going around there, just top to bottom. What is the lowest number on here? It's right here. Let's round that. That looks like -2 1/3, right? So -2 1/3. And I understand that's just an approximation, isn't it? That's okay, just an approximation. We're going to use just as an approximation. What is my highest? Oh, now, do we need to include, it's an open dot. So is it equal to? No, it's not equal because it's open dot. It means it gets as close as we can to negative 2 1/3, right? But never touches it. Up here, my highest is positive 2 1/3. Does it ever get to 2 1/3? No, open dot means it's not equal to. So our range is from negative 2 1/3 all the way to 2 1/3. Okay? All right, so now, oh, look at this. We have some function notation, right? F of negative 2. So we know that F of negative 2 means x is negative 2. So let's look here. X is negative 2 right here. X is negative 2. What are my possible values of y? Well, I could be negative 1 or I could be positive 1. So negative 1 or positive 1. All right? Let's look at when our x is negative 3. What's the only value could be when x is negative 3? That would be 0. Remember, our y value is 0. I come over on my x and my y value is 0. Now this is asking the opposite. This is asking like y equals 1. Y equals 1. So if you think about this, here's y equals 1, the line y equals 1. And where does that touch the graph? Right here. All right, and what's that value? Y equals 1, that is at negative 2. So x equals negative 2. All right? And last question, is the relation of function? Well, if you check right here, there's a vertical line and it hits in two places, so no, this is not a function. Not at all. We have a new relation here. It looks like a V. Now, some of you probably know right now a V is an absolute value graph. If you did, great. Let's find our domain. And remember, our domain, we're going to start with interval notation like this. All right, now this one's going to be a little bit tricky. So, what's the lowest value of x? Remember, x, I'm thinking left to right. Lowest is left. Well, it looks like negative 2, but what's that arrow mean? That means it keeps going left forever and ever and ever and ever. Is there ever going to be a lowest limit? No. So I am going to, right now, erase that. All right? In other words, it can go forever and ever left. All right, now I'm going to go to the right. What's my upper limit right? Well, arrowhead at 6 means it could go forever and ever that way. That means there's no limit that way. When there's no lowest and there's no highest, that means it's all real numbers. Okay? So the domain for this one is all real numbers. Let's take a look at our range. Start by drawing it out. Excuse me, that's a y. What's our lowest y? So I'm going up and down. My lowest is down here at negative 2. Have to ask myself, do I include it? Well, there's no open circle here, and it is solid, so I include it. Now I go up. Does it ever stop going up? These arrows indicate that it doesn't, so I'm going to erase this side. So now you can see y is greater than or equal to negative 2. I'm going to write this with the variable first because it makes more sense to read it. Y is greater than or equal to negative 2. Now you have to remember it's open to y, so when I rewrote it and switched it, I had to switch that over there. Let's find this. So the function at 3, at x is 3, come down, my y is negative 1. My function when x is negative 2, right there, is at 2. Now remember, this keeps going forever and ever, so it definitely is solid there. It's not an open dot. The arrow means it goes forever and ever this way. So now we want to find when y is 1. So our equation, y equals 1. We need to be careful on this one because if you look here, y is 1 there and there. So it hits twice, doesn't it? Hits at negative 1 and it also hits at 5. So for this one, we have two answers. So x is negative 1 or positive 5. And last but not least, is the relation of function? Well, I can draw a vertical line anywhere I want on this graph, can't I? And it only touches in one spot. So since that happens, it's yes. It is a function because it passes the vertical line test. All right? Let's go back and try those other two we had and find out those domain and range. So here we go. So our domain and range for this one, again, I'm going to start just like so. So my lowest x, it goes forever and ever left, so I'm going to cross that out. For my highest x, it goes forever. That means all real numbers, right? How about my range? Does it ever stop going down? Nope. So I'm going to cross that one out. Does it ever stop going up? That arrow would indicate no. So that one, again, is all real numbers. Let's try this one. We have our x's and we have our range for our y. So it's my lowest x, 1, 2, 3, -4. And could it be included at -4? Yes, it's solid right there, so it's equal to. And then 1, 2, 3, 4 over here, and is in solid there. So from -4 to +4, those are my x's. My range, my lowest range, 1, 2, -3, and it's solid. So I include it all the way to +3, and it's solid there. Okay? Let's do this one. Find our domain and range. Always going to start the same way. I think this is the easiest way to do it. So what's my lowest x value? Looks like it's never going to go past -2. Is -2 included? It's an open dot, so it's not included. I don't put that. Does it ever stop going to the right? No, never stops going to the right. So now I'm going to rewrite this as x is greater than -2. So all the x's that are bigger than -2 would be included. All right, including 3. 3 is bigger, so there it is. Let's try our y's. What's my lowest y? -2. My highest y, well, so in this case, the domain and the range are very similar. So let's see, find f of 4. So x is 4. What's my value of y? 1. Find f of -1. We're going to have to round this one, right? It looks like it's about 1.5. So it's -1.5. Find x when y equals 0. Y equals 0 is right here, and it obviously crosses the graph at x is 2. Is it a function? Yes, it's definitely a function. It passes the vertical line test. Alright, so pause the video and you try these right on now. So here we go. We are going to start with domain and range. And I'm going to start putting my domain with all possible x's and my range with all possible y's. Let's take a look. To the left. Does it ever stop going left? No. So I'm going to erase that side. Does it ever stop going right? Yes, at 4. Now, do I include 4? Is it solid? No. It's not solid, so I don't include it. So right now it's written perfect. I want all the x's less than 4. Let's try my y's. Does it ever stop going down? Now see, it's tricky. It looks like it's going up, but you have to imagine it keeps going down and down and down. So it never stops going down. How about, does it stop going up at 2? So I want all my y's less than 2. Find f of -1. Go, x is -1, go down, -1. 0, looks like it's 0, 0. When y is -1, that's right here, -1. So x is -1. And is it a function? Yes, it definitely passes the vertical line test. All right, so hope you got that. And I'm going to leave you with a clip from one of Mr. Bean's movies. Actually, this is from his TV show, I think. So I hope you enjoy it. And welcome aboard, Mr. Bean. I'll see the rest of you on the flip side.
Okay?